your software programming classes, you would have heard the term SDLC, or Software Development Lifecycle. So in our world, what that looks like, let me put that in here. So that stands for Software Development Lifecycle. Okay, so in our world, how that's working is because we are developing software to resolve a particular business challenges, the way we approach it is, and I'm going to speak specifically about the service industry software first. We are actually part of a number of associations to whom your HVAC, your plumbers, your electrical contractors, your general contractors, your construction contractors may belong to. And we went in and we spoke to these folks and we understood, okay, what are your challenges today in executing your business? And where we as an organization have made a decision to primarily focus on is what is referred to as the order to invoice life. Okay, so in any business, you have your sales process, your marketing process, which generates your sales. Then you have your sales processes, which then becomes an order at the end of that process. And then you have to deliver on that order. So you have the order, you have the delivery of the order. Then once that is done, you're going to invoice for that order so you could get paid. So we focus on the part when order and invoicing. So we spoke to the folks such as your HVAC folks, your fire inspection, your plumbing, and so forth, and we understood what is their business processes are like. How do they receive an order? How do they then process that order? How do they schedule that order? How do they then assign that order to a particular technician in the field who can then go in and fix the issue? So, for example, let's say at one of the schools or at your home, your air conditioner stopped working. You called your air conditioning service company and you told them your air conditioner is broken. So they take that order and then they have to append a bunch of information to that order. So they need to know who the customer is, what kind of equipment are we talking about, what type of issue it is. Then that order will need to be scheduled. And then after it's scheduled, it needs to be assigned to a technician who then needs to receive that information, who may be on the road today already. And how are you going to get that information to that technician? And once that technician receives that information, he's then going to execute on that order. But in order for the company, the actual HVAC company, to pay the technician, they need to know how much time he's spending at a particular client fixing that particular issue versus perhaps going from one location to another location, which is travel time. So what our software does is track all of this information with the help of GPS technologies as well as user input information, and we organize this information for them. So in our case, how all of this comes together is we have what is called a functional specification document, which is written by functional designers. So their job is to really sit down with the customer, understand what the customer's workflows are within their business, and then document those workflows. We typically depict them using Microsoft Visio. So we put a process flow and a workflow diagram together. And then those people, and then you may recognize job titles like business analyst or workflow process flow designers. They typically fall under the business analyst title. And those folks gather all of the requirements. They then come back, they sit together with the software designers and put together a functional specification document. So the business analyst folks who also have technology background, they must have technology background and know how software works. They may not need to necessarily be able to code, but they must understand how software works and the limitations and also what's possible with what we could do within the software and what can be done in terms of development. So limitations, functionals, possibilities, and specifications of developing such tools. So they will then work with the software engineers, if you will, who are the designers of the software, who bring all the pieces together as one product. And once those guys have produced a technical, so the initial document was a functional specification document based on the business analysis. Then the second piece of that is your technical specification document, which tells, so that's the part that the engineers put together. So if you're familiar with the terms blueprint, so if you're going to go build a building, there's usually an architect who draws up the conceptual design of the building. Then they'll pass it on to engineers who produce all the blueprints. So our guys do the same thing. Our architects, more or less, is your business analyst guys. We also do have software architects who work on the software at a very high level. The business analyst folks then take what the architect has produced in order to ascertain from the customers exactly what the workflow is for that particular client or customer and within their business. Then they go on to the engineering piece, who then put together the blueprints. It may be an add-on to it already what we have developed in the software, or it may be a completely custom piece just for that customer, where the engineers need to figure out, okay, well, we got this piece that the customer wants. How are we going to bolt or integrate this piece into our core product? And once that's done, the moving on with the process, it will then go into our actual development team, whose job is to actually develop it. These are the folks who actually code and bring to life all of this concept to design to blueprint actually comes to life. So these are the folks, if I were to continue with the analogy of building a building, these are the folks who actually erect the walls, lay the bricks, lay the pipes, put in the electrical, put in your water heater and things of that nature. So these are the folks that actually do that. Once they do that, we have a separate team whom we refer to as the application delivery team or the infrastructure team. And what the infrastructure team does is they are responsible for managing the actual hardware layer. So all this time we were talking about the software. And we now, at the end of this process, have built a software that can actually be delivered to the customer and the customer can make use of. However, how do you actually deliver the software? So going back to what I said, what we were talking about previously, software as a service, and since that is the model in how we deliver the service, we now have to take the software, put it at a data center, build the infrastructure for delivering that software at a data center. So what is the infrastructure? So these are things like your servers. So you have your application servers, you have your database servers where the database resides. Then you have your security layer, so our firewalls, as well as, in our case, we have what are called load balancers, because if we have a lot of, right now we have approximately about 30,000 plus business users that access our software every day on a 24-hour cycle. So how do 30,000 people access your software? See, here's one very neat thing about building software is that you could build the software and use and it may be the best build ever. However, the architecture and engineering within that software is greatly impacted by the number of people that are going to interact with that software. So that is something that every person that architects a software must always be thinking about. The way you're designing the software, the way you're writing your code, the way you're referring to classes, the way you're referring to objects, the way you use those objects and classes within the logical piece of your software. Can it handle the kind of volume that you want to expect to have, right? So I told you in our case, We have currently about 30,000 plus users accessing our software on a daily basis. If you look at guys like Facebook, I'm sure you guys all know about Facebook. You got millions and millions of users. In fact, you got hundreds of millions of users accessing Facebook on a daily basis, right? So how does the software be able to sustain that level of use, that level of interaction? So that in itself is a two-part game. One part is how you've developed the software, the architecture of the software. Going back to what I was saying just a bit ago, how do you access classes, objects, logics? How do you use them in the software? Even as something as simple as randomizing something, right? What type of tools or code sets do you use to do that? Because that will greatly impact, and this is another very important term that you guys should be aware of if you're going to go into the software world, user experience, or what you may have heard as UX. So you may have heard the term UX designers, UX design, things of that nature. So what does UX mean? Is user experience. Very important. Because if the user experience is not good, people are not going to use your software, which means you're not going to be able to sell the software, right? And even if it's just free software like Facebook, they're all dependent on a massive user base to generate dollars through advertisements. In order to gain that massive user base, your application needs to be user-friendly, it needs to be user-intuitive, and all of that combined together, the industry terminology for it is called user experience or UX. So that's very important. That's part one. Part two is the actual hardware layer that then enables your software to be available on the internet.